What causes oscilloscope aliasing and how can you prevent it? Imagine trying to capture a fast-moving object with a camera. If your shutter speed is too slow, the object looks blurry or distorted. The same idea applies when using an oscilloscope to measure electrical signals. If the sampling rate is too low, the displayed waveform can appear wrong or misleading. This problem is called aliasing. Aliasing happens when the oscilloscope samples an input signal at a rate that is too slow to catch its true shape. The key rule here is the Nyquist sampling theorem. It states that to accurately reconstruct a signal, the sampling frequency must be at least twice the highest frequency component of that signal. If you do not follow this rule, the oscilloscope can misinterpret the signal. When the sampling rate is too low, the high-frequency parts of the signal fold back into lower frequencies. This folding causes the waveform to look slower or distorted. Think of it like a mirror reflecting a high-speed object as a slow-moving image. The oscilloscope's analog-to-digital converter takes discrete samples of the continuous signal. If the samples are too few, the true waveform gets misrepresented. Several factors can cause aliasing. First, if the oscilloscope's sampling rate is below the Nyquist rate, aliasing is almost certain. Second, setting a long time base reduces the number of samples per cycle, increasing the chance of aliasing. Third, limited memory depth means fewer samples can be stored at high speeds, forcing the scope to lower the sampling rate. Fourth, if the input signal contains high-frequency noise or components above the scope's bandwidth, these can fold back into the displayed waveform if not filtered properly. To prevent aliasing, start by ensuring the sampling rate is at least twice the highest frequency you want to measure. Many modern oscilloscopes have high maximum sample rates, making this easier. Adjust the time base to a shorter setting, which increases the sampling rate and captures more details of the waveform. Also, use the scope's memory wisely. More memory allows you to sample at higher rates for longer periods. Applying an analog low-pass filter before the signal reaches the scope can remove high-frequency noise and prevent folding. This filter is called an anti-aliasing filter. It blocks frequencies above half the sampling rate, keeping the displayed waveform accurate. Using features like autoset or peak detect mode can also help optimize the sampling and trigger settings to reduce aliasing artifacts. Finally, if the waveform looks strange when you change the horizontal scale, it might be a sign of aliasing. Try zooming in or out and see if the shape changes drastically. If it does, increase the sampling rate or adjust the filter settings. In electrical measurement, avoiding aliasing is essential for getting true readings. It helps prevent misinterpretation of signals, ensures accurate frequency measurements, and makes troubleshooting easier. By understanding the relationship between sampling rate, signal frequency, and memory, you can set up your oscilloscope correctly. This way, you get a clear, faithful picture of the electrical signals you are studying.